Welcome to Knowledge Gainer 1M channel. Today our topic is permutations and combinations. The formula is from n distinct elements, selecting and arranging r elements is denoted by NPR. 0 less than or equal to r less than or equal to n. This is without repetition. And for combination from n distinct elements, selecting r elements, NCR. 0 less than or equal to r less than or equal to n. Factorial. N factorial is equal to n into n minus 1 into n minus 2 into n minus 3 and so on till 1. For example, 5 factorial is equal to 5 into 4 into 3 into 2 into 1, that is 120, and 4 factorial is 4 into 3 into 2 into 1, that is 24. We should note that n factorial by r factorial is not equal to n by r whole factorial. Let n is equal to 8 and r is equal to 4. That is 8 factorial by 4 factorial is 8 into 7 into. Now the same numbers get cancelled. Now 8 factorial by 4 factorial value is 8 into 7 into 6 into 5. But now 8 by 4 whole factorial is equal to 8 by 4 is 2. 2 factorial value is 2. So 8 by 4 whole factorial is not equal to 8 factorial by 4 factorial. We know that permutation NPR is equal to n factorial by n minus r factorial. We also know that 1 factorial is equal to 1 and 0 factorial is equal to 1. Now NP0 is n factorial by n minus 0 factorial, that is n factorial. So NP0 is 1. NP1, that is n factorial by n minus 1 factorial. We get this value as n. NP1 is n and NPn, that is n factorial by n minus n factorial, which is equal to n factorial by 0 factorial is 1. So we get this as n factorial. Combination NCR is equal to n factorial by n minus r factorial into r factorial. 0 less than or equal to r less than or equal to n. Now NC0, that is n factorial by n minus 0 is n factorial into 0 factorial. N factorial by n factorial is 1 into 1. That is we get this as NC0 is 1. NC1, n factorial by n minus 1 factorial into r factorial is 1 factorial. We get this value as NC1 as n. Again NCn, that is n factorial by n minus n factorial into n factorial, which is equal to n minus n is 0 factorial, that is 1. So n factorial by n factorial, we get the value as 1. Let us see some important points. NPR is equal to r factorial into NCR. NCx is equal to NCy. Then x is equal to y or x plus y is equal to n. The number of permutations of n things of which p are alike and of one type and q are alike and of one type and the remaining all are different. Then the number of permutations is equal to n factorial by p factorial into q factorial. Fourth point, if a work is done in m ways and the second work is done in n ways, then both work together one after the other can be done in m into n ways. If three works m and p together can be done in m into n into p ways. Now let us see a question in permutations. If NP4 is equal to 360, find n. NP4 can be written as n factorial by n minus 4 factorial is equal to 360 is given. N factorial by n minus 4 factorial is n into n minus 1 into n minus 2 up to n minus 3. Here r is 4. So take 4 terms which is equal to 360. Here the LHS side is the product of 4 consecutive integers. So 360 should be expressed in the product of 4 consecutive integers. Now these are the factors of 360. The greatest factor is 5. The integers before and after 5 are 4 and 6. 4 and 6 are also the factors of 360. So from this we get the 4 consecutive integers as 6, 5, 4 and 3. So the value of n is equal to 6. Second question, how many number of 4-digit numbers can be formed with digits 1, 2, 3, 4, 5 without a repetition? From the question, n is equal to 5 and r is equal to 4, that is number of places to be filled is 4. The number of 4-digit numbers formed is 5p4, that is NPR. 5 factorial by 1 factorial. 5 factorial is 120. So 120 4-digit numbers can be formed. Third question, how many numbers between 400 to 1000 can be formed with the digits 2, 3, 4, 5, 6 and 0? Here no information about the repetition is given, so assume that repetition is not allowed. 3. Any number between 400 to 1000 must be of 3 digits only, but the number to be between 400 to 1000, it starts with 401 That is either it start with 4 or 5 or 6. So this is 3 ways. If one number occupies the first, out of these 6 numbers, only 5 numbers from which only 2 numbers should be selected. So this is 5p2. Now the required answer is 3 ways into 5p2. 3 into 5 factorial by 5 minus 2, that is 3 factorial, which is equal to 60. Fourth question. How many even numbers of 4 digits can be formed with the digits 0, 1, 2, 3, 4, 5, 6, no digit being used more than once, that is no repetition is allowed. Here the number of digits is 7. We should form a 4-digit number. To make this as an even number, this units place should be filled with either 0, 2, 4 or 6. If the units place is occupied with 0, this is of 1 way, and other 3 places should be filled with the remaining 6. So 6p3, that is 6p3 into 1, which is equal to 6 factorial by 3 factorial. We get this as 120 ways. If the units place is filled with either 2 or 4 or 6 other than 0, this is of 3 ways. But we can't place 0 here. So there is a possibility of only 5 numbers. One number is occupied in this units place and V0 we cannot fill here. So that is 5p1, that is 5 ways. Here the remaining 2 places should be filled with the remaining 5 numbers. That is here 1 number and here 1 number is taken. So remaining 5 numbers, of which only 2 numbers should be selected. So 5p2. So from this the number of numbers formed is 5 ways into 5p2 into 3 ways. That is 15 into 5 factorial by 3 factorial. We get this as 300 numbers. So the total number of numbers required is, 300 plus 120. That is 420 numbers can be formed. Fifth question. How many positive numbers can be formed by using any number of the digits 0, 1, 2, 3, 4 without repetition? Now let us consider the 5-digit case. To make this as the 5-digit number, we can't use 0 here. So they should be filled with either 1, 2, 3 or 4. That is 4 ways. One number is occupied here. So the remaining 4 places should be filled with 4p4 ways, which is 4 into 4p4. Now let us consider the 4 digits case. Here also we cannot fill it with 0. We should either fill it with 1, 2, 3 and 4. It is 4 ways. Here the remaining 3 places should be filled with 4p3 ways, which is equal to 4 into 4p3. In the 3 digits case also we cannot fill it with 0. We should either fill it with 1, 2, 3, 4, that is 4 ways, and the remaining 2 places should be filled in 4p2 ways, that is 4 into 4p2. In the 2 digits case also 0 can't be filled in this place. 1, 2, 3, 4 can be filled, so 4 ways. This single place should be filled in 4p1 ways, that is 4 into 4p1. When this is of 1 digit case, the number of positive numbers formed in this case is 4. Now the number of positive numbers formed, we should add all these values in each case. So 4 into 4p4 is 96. The next value is also 96, and 48 plus 16 plus 4. On adding all this, we get this as 240. The number of positive numbers formed is 240. Number of permutations of n different things taken r at a time. When the repetition is allowed, any number of times is n power r. Sixth question. A man has 6 friends to invite. In how many ways can he send invitation cards to them if he has 3 servants to carry cards? Here all the servants cannot carry the cards to the same friend, but one servant can send the cards to the different friends. In this case, we should take n is equal to 3 and r is equal to 6. That is n power r is equal to 3 power 6. So the value is 729. A letter log consists of 3 rings, each marked with 10 different letters. In how many ways it is possible to make an unsuccessful attempt to open the lock? In this lock of 3 rings, 2 rings may have the same letter, that is A and A. But a single lock doesn't have the 2 numbers, which is impossible. So in this case, n is equal to 10 and r is equal to 3. That is n power r, 10 power 3 is equal to 1000. So the number of attempts is 1000, of which only one is successful, by which the lock is opened. So 999 is the number of unsuccessful attempts. Eighth question. How many numbers greater than 1000 but not greater than 4000 can be formed with the digits 0, 1, 2, 3, 4 with repetition? Now according to the question, the required number should be greater than 1000 but less than or equal to 4000. Let the number be x. From this we understood that we should find a 4-digit number. Here the total number of digits given is 5. But here we can't use 0. If we use 0 here, this becomes a 3-digit number. So the number of ways this can be filled is 3 ways. We can't use 4 also here, because if we use 4 here, this becomes greater than 4000. So we should eliminate 4 and 0. So the number of ways we should fill this is 3 ways. 1 digit is occupied in this place. So we can fill this place in 5 ways, and this place in 5 ways, and this place in 5 ways, as repetition is allowed. So the required answer is 3 ways into 5 into 5 into 5. We get the value as 375 numbers. See a note point. A group has m things, B group has n things. Number of ways in which no two of the group B occur together are m plus 1 p n into m factorial. Ninth question. In a class of 10 students, 3 are girls. In how many different ways can they be arranged in a row such that no two of the 3 girls are consecutive? Here given number of girls is 3 and boys is 10 minus 3 is equal to 7. So take n as 3 and 7 as m. Substituting these values in this formula, m is equal to 7. So 7 plus 1 p n is 3 into 7 factorial. So 8p3 into 7 factorial. This can be written as 8 factorial by 5 factorial into 7 factorial. Now let us see another note point. The number of ways in which m exam papers be arranged so that the best and the worst paper never come together is n minus 2 into n minus 1 factorial ways. 10th question. In how many ways 10 exam papers be arranged so that the best and the worst papers never come together? Here n is equal to 10. Now substituting the values, 10 minus 2 into 10 minus 1 factorial ways, that is 8 into 9 factorial ways is the answer. Please like, share and subscribe to Knowledge Gainer 1M channel and press bell icon to get notified. Thanks for watching.